Hello, good afternoon. Good afternoon, everyone, and thank you for joining today's webinar. Today, we are presenting webinar on Humane Maths, Combine Creativity and Rigor for Maths, which is organized by Applied Science and Humanities Department of Parul Polytechnic Institute, Parul University. We will be running live question and answer sessions at the end of the webinar. If you have any questions, then WhatsApp us on 7016390124 or 98980 38375. I would like to introduce today's presenter, Monica Kocher, a mathematician. She is an author, facilitator, curriculum designer for math subject. She has given numbers a heart and abstract concepts a ground to stand upon. Her way her way of maths curriculum is based on understanding that any program requires focus on thinking, feeling, and doing. With this framework, strategies are to be taken from best practices for brain-based learning and integrated with maths to create a learning environment where all can learn maths without any fears. She has worked with CBSE, ICS, and international curricula and has worked as specialist support to special need students. It's our privilege to welcome you, ma'am.
Yeah, thank you so much. Thank you, ma'am, Vishali.
Thank you, ma'am.
Shall I start?
Yes, you can start with the presentation.
Okay. Thank you so much for inviting me. This is a very unusual presentation for me. For most of my audience is engineering graduates, and therefore you are doing maths at a level which is really higher than something that I have done or my students have done. But I'm very interested in the whole program because it is very rare that an engineering college or university also talks about humanizing the classroom and bringing the whole idea of being human into engineering. So I'm very happy to be here and I'm very privileged. This is thank you so much to Hemal for organizing this. Humane maths is a term that everybody feels very interested in knowing about. So this is a term which was given by a group of my students who said that your classes respect us more as a person than as a math student, and therefore we think your whatever maths you do, we will call it as humane maths. So I would give you a bit of understanding about it. We would just 1 second. I would start my presentation to kind of show you what exactly do I mean by it. So normally when we say maths, we mean rigor, which means there should be a very authentic command on maths concepts. So if I am doing differential calculus, I should know exactly what differential calculus is, what are the formulas for it, which formula to be used when I'm doing which problem. That grip is really necessary. On the other hand, creativity is when I have a chance to create something new, where there is an originality. Let's say a design, I'm designing a machine, or I'm designing an art piece, or I am writing a paper. So I have the chance to bring something new to it. Now, what happens in maths classroom is if there is too much pressure on this rigor, you have, as is the present state in so many classrooms, that you have about 10% of students like maths and the other students are very frightened of maths. And in some places, it's even lesser. And on the other hand, in schools, let's say in the Western countries, some of the countries, if there is too much pressure on creativity, that you are doing art and music and dance with maths classes again and again and again, their grip on maths concepts becomes weaker. and therefore they are not able to do the maths which is required to, let's say, clear the exam, or the maths which is required to do engineering or higher level maths. So I'm going to bring to you examples from school maths, but the idea is that both of these need to be combined, which means that whenever a classroom experience is created for children, there should be a combination of stress on learning the maths, but also a certain stress on creativity. So I'm going to go through this presentation with lots and lots of examples. And in between, I may pause and ask you a question. But like Vaishali ma'am said, that questions will be taken in the end. So you can think of the answer. And if more questions are there, you can just make a note and we'll have a round of question and answers in the end. So one thing, and this I'm saying to you as faculty or as students of maths, or if you are engineers, students now, you will be engineers later, you will probably be managers, you will be leaders. So I'm talking to you as maybe present or future mentors, because all good leaders are mentors. They are not like bosses. So one of the things that you should bring in your life is writing about whatever mathematics that you're doing. And writing as in writing a paragraph, or writing even an essay, or even writing 5-6 lines, because what it does is maths is completely in the left side of the brain, writing is on the right side of the brain. So when you write about maths, the whole of the brain, the entire neurological structure is involved in learning something. And as anyone who understands brain logic would know, that when the whole brain is involved in learning something, then that learning goes deeper. So here is an example. So this is a very logical part of maths which is done in middle school and high school, which is information graphs. A lot of kids have difficulties with it. It's an information graph is where you have distance versus time graph, and the speed is there, and you need to look at the graph and find out what is the speed at this time, what was a person doing between 9 a.m. and 10 a.m. So you have to see if looking at the slope of the graph, you would know whether the person was stationary, moving forward, backward, and all that. So students have issues with this. So what I would do in a classroom is, I would say, just write about it. And when you say write about it, most of the people are completely blank. I don't know what to write about it. So give some questions. And the best way of asking questions is what, who, how, what again, where, what is an information graph, who needs it, how do we draw it, where did it start. So these are very simple preliminary words that you can use, and questions are created. If you're doing it for yourself, great. If this is an assignment, let there be some score for language, some score for maths, and some score for complete final accuracy. So there is real life math, there is writing about it, and there is a scorecard which says assess everything. So writing is something I found, especially in students who any concept that a student finds hard to grip. If the student is just asked, just write something about it. And I have found it again and again and again that the students, by the end of it, they are able to either grasp it, or they know exactly where their learning gap is. This is one idea. This is something which, at least in most of the schools in India, nobody believes that poetry can come in maths classes. But every poem which is written on a topic. So why not take a maths topic? So I've seen teachers teaching for 30, 40 years being able to write a poem. This was written by a student. This was like a calendar that went on. And he wrote about angles, obtuse, straight, reflex. And this was a student who was a genius in maths and a genius in language. So what poetry does is, there is poetry, there are colors. And when you're looking at these ideas, just think, what are the various skills which are coming into this particular maths topic? And that's how I would be happy if you can look at each idea. For example, here, a lot of emotions are coming in. because there are colors, there's poetry. Poetry itself, writing the poetry, which is rhyming, is a very logical exercise. The student is thinking about the concept, so the concept is going deeper. So, in this way, just think about what are the skills that the students are learning in the classroom. Because while your subject knowledge takes you to exam, and your exam takes you to, let's say, a job interview, beyond that, it's skills which are needed. And those skills are learned best in the classroom. So, this is one example. Uh, Flip the learning is something that I can just go on and on. It is very simple. Today, it has become a really big thing that you go to a website, then you learn something, then you do a quiz, and then you come back and we discuss it. But I have a friend she's really old, but she's very young in her head. And she said when she was a child, she said, our Master Ji used to say one day before, read this chapter, come tomorrow, and we will have a discussion. Isn't that flip the class? I said, yes. So it's as simple as that, that a teacher or can say to the students, this is the topic I'm going to do tomorrow or next week or day after tomorrow. Here is the content I want you to read before you come for the class, and we will have a discussion. Gradually, and this content can go from a website, it can go from a textbook, it can also be something that, okay, students just research about percentage or research about integration of polynomials and then come back and we will discuss it. So what it does gradually, in my experience, is that students start becoming independent learners. Slowly and slowly, they discover that there is so much of math that they can learn themselves, that they don't really need to depend on a teacher. And one of my students told me at the end of the year that the best gift you have given to me is showed me Google, what is available on Google, that I can learn it myself. And this self-sufficiency then removes the stress on the teacher to be the person who has to get everything known to the children. So this dependency of students on teachers, which is very much a hallmark of traditional education setups, starts slowly changing into an independent student and a less stressed teacher. And flip the class today is happen everywhere, because teachers are teaching via Zoom in school education, and they are looking constantly for ways and means to teach in a friendly way, in an exciting way. And a lot of teachers have discovered that if they flip the class, if they give students something beforehand, it really works very well. So this is something I would say it should be like mandatory practice in all classrooms. The other is, I think this is like connected with flip the learning, is research. We are in a century when there is an information explosion. I want to know about, let's say, COVID-19. There are millions of websites. I want to know about Sushant Singh Rajput's death. There are again millions of pages about it. I want to know what's happening in Bollywood post Sushant Singh, which is really the hot topic. Again, millions of. I want to know what's happening in New Delhi, because there is this confusion between center and state regarding rules for the COVID patients. Again, there are millions of websites. How do I process this information when there is bombardment from all sides? And that happens, you learn when you learn to research, when you start asking questions. Is this really true? I'm looking for information on where do I go if I feel ill in New Delhi? Do I listen to the chief minister? Do I listen to the lieutenant governor? I need to know how to collect information, how to analyze it, and therefore I need to know how to do my research. And this starts in the classroom. So let's say there's any topic under the sun which is given to the students, and they are given some key questions. If students are told just do research, it doesn't work. They need to be given very pertinent questions. What are you looking for? Again, what, how, what, where, who. So let's say you want to do some bit of research on Euclidean geometry. What is Euclidean geometry? Who invented it? Why did it start? What is the use of it today? Why are we learning it? And then which website is reliable to look for this information? Who has published it? When was it published? All of this goes into research, which is now one of the mandatory skills today because we are so dependent on internet for most of the information. Uh, Artistic designing, this is a very special project because this was one project where I found I had kids in my class who wouldn't learn. They were like on strike for maths. They didn't want to learn anything. And I tried everything under the sun. And finally, I told them that we really need to reflect on what are we doing in this world. And if you don't want to do that, you don't want to do anything creative, then I'm going to go back to the way my teacher taught me, which is I will just write answers on the board and you copy because then nothing seems to be working with you. So my last task with them was I asked them to design a logo of your life. And that logo has to represent who you are. And you also need to write down about it. And to bring in maths, I said your logo should have minimum one line of symmetry. It can have more, but it should be absolutely a perfect line of symmetry. And this is the project which completely changed the class because they found a class where there was not only maths, but they felt that they were also given the space to explore who they were. And that's what connected them with maths. And there were no issues after that. So, for example, this kid created a logo where he said, if you look at this picture like this, it's a smiley face. If you turn it around, it's a sad face. And he said, this is how life is. You know, you look at it, depends on how you look at it. You look at it in this way, it's smiling. You look at it upside down, it's a sad life. But it wasn't about the logo. It wasn't about the designing. It wasn't about the maths in it. It was about that the children felt welcome as human beings in the class. They felt that I matter as a person. I am not just one or two lines of symmetry or a order of rotation symmetry. Me as a person also matters. And that's what gave them a lot of comfort to be in the class. And these were teenagers who needed to feel that, you know, we are important. So designing can be done anywhere. And those of you who are engineering students, you're designers, um, design a logo of your life or design a logo of somebody else's life, or think that you're recruited by a company, fictitious company, which one of the students did that. He said, I don't want to design logo on my life. My life is perfect. So I said, okay, design a logo on a company. And he thought of it and he came up with a brilliant design for a shoe company. So convert your mathematical knowledge into something creative through designing. It can be a logo, it can be a building, it can be anything under the sun that you're doing. So this way, once again, the neural structure in the brain moves from left to right, from right to left, and the whole brain is involved in learning something, which means your head is involved, your heart is involved, your hands are involved. And that's when learning becomes real joyful. And exploring design such that also helps you to ask questions. Why am I here? Why am I into an engineering college? What is my goal? And am I fulfilling that goal? Let's say your goal could be, I want to design something unbeatable. Your goal could be, I'm in it because I just didn't know where else to go, or my parents told me. Fair enough. But what do you want to do with this, with the engineering degree or any other education that you are undergoing? Where do I want to be? And a kind of a logo which helps you to explore yourself, helps you to also look forward and be a, I would say, more evolved citizen of the country or the planet. So this is designing. Art, once again, I won't stay long for it. Once again, so much geometry is done in construction of shapes. and it's one of the most boring chapters. But at the end of construction of shapes, if students are told, okay, now give me a design again with lines of symmetry and all sort of mathematical rules in it. For example, use minimum 3 geometrical shapes. They should be constructed perfectly using ruler, compass, protractor, and your design should have at least one line of symmetry and either color it or shade it. Now, all the math comes from the rigour side. I want the kids to learn how to construct the shapes properly. All the shading comes from the right side, which is the creative side of the brain. And this kind of a work, which is generally graded, assessed, marked, and the marks go into the final score, helps the students to connect the two. Again and again, children who are math phobic, if these two things are done with them, or even if art is done with them, 99.9% guaranteed from me, maths phobia has no place in such a classroom. So this is the kind of the beauty of art. Now, what if you're teaching only on the board? And what if your board is also not a whiteboard with marker, which is a privilege that is not for all the teachers? So I started with a blackboard and I started with colored chalks, white chalks, and then I requested the school for colored chalks. If whenever we are doing steps like these, for a student who is still trying to understand math, it's very confusing. For us, it's very easy. Ratio, cross multiply, find the value of x, answer is 60. But a lot of students need to know step 1, do this, step 2, do this, step 3, step 4. And when you tell the children, step 1, form the equation, step 2, cross multiply, step 3, solve the equation, step 4, find the value of x, it really makes a difference. And I mean with fingers like this, because you have a visual, you have an auditory, you're speaking, and it goes deep into the minds of the students. So just using double color content on your board can make such a huge difference if all you have to teach in your class is a board and a marker, or a blackboard and a couple of colored chalks. So this also breaks a full question into small steps, what we call baby steps, that you first learn to crawl, then walk, then stand, then walk, and then run. So if a child is not able to grasp full solution, like in higher maths when I was doing my masters, there were proofs of theorems that went to 4 or 5 pages. And you had to know the whole of it because anything would come in the exam. So a professor in the masters, one of the subjects, functional analysis, the professor was absolutely amazing. He used to break that 5-page theorem into small chunks. And he would say, do this, then come to this. And we breezed through his syllabus. And now I understand that he broke it into baby steps. So all of us performed. That was a subject function analysis where we all perform best. So this is what is baby steps. That anything, even if you're learning something by yourself, break it into chunks, one chunk at a time, and then go to the next, and then the whole thing falls together in your head. So this is one strategy. So what I'm giving to you are strategies which is like, these are the experiences that can come into a classroom to bring rigor and creativity both together with lots and lots of life skills. For example, life skill of research, life skill of self-awareness, which is the in thing now, thankfully, finally, knowing yourself. Life skill of designing an original design, which means giving an expression to your own originality. Life skill of breaking a big challenge to small steps. For example, when COVID-19 struck, I was on the first day frozen. What are we supposed to do? You know, this is such a huge issue. I have responsibility of my mother with me and I have projects. What am I going to do? So I said, okay, this is a huge problem. I cannot cope with it. I don't know what to do because there's no vaccine. COVID symptoms change every day. Let's break it into steps. What's my first step in case urgency strikes? Even before anybody gets infected in my family, What should I do? So slowly and slowly, strategizing it, I'm able to manage the whole thing and do my work, and everything goes. So learning baby steps is an incredible life skill for all of us, um, which is needed no matter what we are doing. And in maths, it's really needed for those students in the class who are absolutely frightened when the whole board is covered with maths. They completely switch off, they go into their dream world. But if on the same board colorfully it's given, this is the first, this is the second, third and fourth, their focus comes back, because instead of focusing on the whole thing, they have to focus only on this. And in the final exam, even if they get number one and number two correct, they get something, and that gives them a good feeling. Then I don't think maths is possible without reasoning. I don't think life is possible without reasoning. As they say that, and Jiddu Krishnamurti, a South Indian philosopher, teacher, he said, an unexamined life is not worth living. And reasoning is maths, maths is reasoning. So even when you're doing purely mathematics, why? How do you know? Let's say, what is derivative of x square? What's the answer? And I would ask, how do you know? Can you justify? What's your logic? You know this is a formula. How do you know this formula is? How do you know this works? Can you explain your solution? Where did this formula come from? So depending on how much one can push students, that many questions need to be constantly asked. I think I have gone as low as even a student, I would say, why is the answer 5? And the student would say, because it's 2 plus 3. And so how do you know 2 plus 3 is 5? Can you give me a logic behind it? And the students actually thought about it. These were high school students. So, and or why do we need to know about prime numbers? How do you know 2 is a prime number? Or how do you know 2 is the smallest prime number? So if reasoning is constantly developed, I think more than knowing maths, being able to reason about it is much more valuable for both exams as well as life than just knowing the mathematical concepts. So I think reasoning is, as I said, it's math, and again, it's a life skill, because every information that bombards us from internet or from advertising boards, if we just learn to reason it out, is it possible that this particular brand of this item is the best? How do we know this is the best? Is it because Shah Rukh Khan is advertising it? Therefore, like they say, whichever advertisement Shah Rukh Khan comes in, the sales increase. So why is it that Shah Rukh Khan coming in the advertisement increases the sales? Is it something that, is it right? Or should I think about it? Should I think whether this product is really useful for me, or should I just buy it because Shah Rukh Khan is there to sell it? So he might be getting maybe 1 crore per 5 seconds to do this. But does that mean that I should buy it? So without reasoning, it's hard to live life. And without balancing reasoning with emotions, feelings, also, it's really hard to live life. So that's why I would say all of this is needed. Usually the maths content, if it stays only in reasoning, a bunch of students will like it who are primarily reasoning oriented, which is left brain. But if you bring in certain side of humanity into, or humanize the maths classroom by bringing the humanities side of learning, then it's much more accessible to all children. And we will have children coming out of 12th not saying I hate maths, but yeah, I'm okay in maths and it's fine. So this is reasoning. This is another thing which I feel should become mandatory in classes, which is 4 types of settings. Students working alone, students working in partners, whole class, small group discussions or small group work. And mind you, everywhere it's maths that could be happening. So a student could be solving a worksheet alone. A student can do it with a partner. A student can do as a group discussion. and a student can do as a small group discussion or a whole class discussion. And I don't think I need to tell you, you learn to be independent when you're working alone. You learn to be aware that you're in a huge group in a whole class discussion. You learn interpersonal skills in a small group discussion, and you learn to be kind. Whenever teachers ask me, half of my class understood and half of my class didn't understand, I would say pair them up. One who has understood, one who hasn't understood, let them learn. So the bright kid will learn how to be kind, and the weak kid would learn from a bright kid. And sometimes students have come back, and even teachers have come back and said, the way students taught each other, it was better than what I could have done. And once again, instead of having the stress on the teacher to ensure all these 30 students have learned, the work gets distributed. It gets balanced in the classroom with others, and the teacher gets kind of a resting phase. And discussion with each other is what prepares students for teamwork later in life. And as they say, more and more in organizations, they are looking for people who are team players more than students who have got good grades or students who are from top universities. They're looking for people, are you a team player? That's the question they ask. And I would say all the skills are needed to be a team player, to work alone, to be in a huge classroom discussion, and to be able to sit with a friend and just very gently teach. Like, for example, I went to a village school in Gharonda. It's in Haryana, and you have to go way through lots of Khet Khalihan to reach there. And I was talking about settings with the teachers, and one teacher gave me her experience, and she didn't know. She just did it very spontaneously, as all great teachers do that. She had half the class teach the other half for science. And she created buddies in the class. And she said buddy teachers were so responsible of the others that they would say, oh, you didn't understand this in class, tujhe ye samajh mein nahi aaya, chal main tujhe samjhata hu, let me help you. And those were the children who used to come via all the farms on their cycle or on foot. So the buddy teachers would say, let's go back together, let's go to home, and I'll come to your house. And she said the whole class's result went up because one strategy she adopted, that was buddy teaching. And she said, ma'am, my own stress and my sadness that I'm not able to reach out to all the children reduced because the children were teaching each other. And I can spend that time in learning to be more creative about teaching science. So this is something, buddy teaching and group teaching is something that is considered as two of the top strategies in the world. And it teaches the kids interpersonal skills, because the moment you do it, you realize there'll be one group that will be working very well, there'll be one group that will always be fighting, and there'll be some groups which would be okay. And that's how you slowly tell the children that I'm doing this because I want you to learn to work with others, because that's a life skill. And my favorite reason used to be, I don't like everybody in my department, but I need to work with them. So how do I work with someone who I don't like? And that is a skill needed. And I haven't found students who weren't convinced when they heard that. But since it's not possible to do this always, rotate it, which means at least once a week, let them work in groups. At least once a week, or whenever they have half the class has doubt over something, let them work as buddies. This is very common, and this is very common. But rotate them so that they get the experience of different ways, and the classroom never is boring, and the kids learn maths from each other. And this is for kids who love nature. And this is also for the winter time when it's too cold and there's a nice sunlight outside. Take maths outside. There is so much of maths outside. So in trigonometry, there can be heights and distances, build a clinometer, go find height of something, anything. You have a building and then question them. Should you be on the same level as the building to find height of the building? Should you be on the lesser? What if the building is on a higher level and you are on a low level? This is a pair of children who were using ratio and proportion to find height of their school building. Another group of children went to find height of, let's say, the basketball pole. A third group went to find height of a huge residential complex that was next to the school where those children lived. So they said, we want to find height of the residential complex that we built. A fourth pair of children just took this shrub and said, we'll find height of this. So I let them, then I asked them, do you really need ratio and proportion to find height of this? Something which you can just use a ruler. And then we had a good discussion on when do we need mathematical tools? Which tool do we use? Do I just use a ruler? If I have to find height of a building, do I use a ruler? Is it better to use ratio proportion? Is it better to use a clinometer? So when is a clinometer helpful? And they realize that there is so much of maths, outdoor. You have a spherical tank. How do we find volume of this tank when we don't have a formula? What do we do with it? A teacher, he took kids, and if you see these pillars, he just took the kids out and he said, can you tell me what's the volume of this particular pillar? And no prior information. And the kids had to figure it out. How do we find volume of this pillar? And then the teacher said, let's figure out what is volume of a certain brick. And then how many bricks were used to set up this pillar? And what's the cost of one brick? And on and on and on they went. And finally, they actually tried to work out what was the cost of all the bricks that were used in building the school building. And they did a very good cost analysis. And if the bricks were bought from here or here, eco-friendly, non-eco-friendly. But the point is that going outdoors is what makes maths come alive, because you see it all around you and you see, wow, my God, this building couldn't have been built if there was no math. And therefore, it needs to go out at least once a year or twice a year, or maybe like in Delhi, every winter, at least twice, it should go out when the weather is really nice because it's all sunny and everybody is happy doing it. And real life. This is another thing where you can design. So you have angles, vertically opposite, obtuse, acute. And the only thing I told the kids was design a street, but I want to see all the angles. So it could have been a street, but I can also say I want to see just a design of something from real life. It can be a house, it can be a room, it can be a flower, it can be a garden, it can be a street, but I just want to see all the angles in it. And this particular kid decided to create a street, which is an original from where she lives. So she walked around the space and she actually discovered that, ma'am, the angles are generally on the roads are right or obtuse or acute. And she was very curious. She went ahead to find out, why are these angles used? When are obtuse angles used on the roads? When are right angles used? Is it true? Is it also on a highway? What happens on a flyover? Is it on the roads? So certain cities, for example, Pondicherry, Chandigarh, they are all created using right angles. So all the streets are parallel, and when you turn, you're turning at a right angle. So what's the use of it? You're never lost, because you know that it could be few streets this side or few streets this side. And I find when I go to Pondicherry, I'm never lost because I just need to walk a little and I find it. But there are some cities where the streets are different. So you can start from a simple thing like angles, which could be a middle school concept, and take it forward to senior school as, why is it the way it is? What is behind building the roads, the design for building the roads? It could go into high school as a research work. It could go into senior school or graduation as, let's go talk to an engineer and find out, how do you decide what to do over here? And for example, one of my colleagues, he was a maths teacher and an accounts teacher. And the first thing he would do when he had his grade 11 was, let's all visit a factory and see how the ingredients for pizza are created, or let's go and see how a pizza is created. And from there, how do they do the cost analysis? What do they do? How do they find profit? He came to accounts. So bringing real life into maths is something which Indian national curriculum in school lacks, and that is the reason maths remains very abstract. So the kids keep thinking and wondering, when am I going to use this? What's the use of it? And since they keep thinking, I don't think there's any use for it. They lose interest in it, and then they are told, no, you have to do it, and that's where the fear comes. So I don't think there is any topic in maths which is useless. We just need to be able to find, and in my career as a consultant, before that a teacher trainer, before that teacher, I have been able to find a use for every concept at any level. Somewhere or the other you will find that yes, these are the people who use it. And engineering, of course, is a complete applied math science. So bring real life into the classroom, do real life projects so that you understand what this is all about. And okay, so I'm pausing a bit here. I've done these 9 things with you, and there'll be another maybe 5 to 10 minutes of more, maybe 5 minutes, and then we can have questions. I have done baby steps, settings, outdoor, real life, art, designing. I want you to reflect here, out of these 9 things, which is the 1 or 2 or 3 ideas that really struck you? Yes, this is very useful, and I'm going to use it in my teaching or in my studying. And if nothing struck you, then why? You might think all of this is of not use. What is it that struck you overall? First question, so far. And second question, how do you think it's going to be used in your work as a student or a teacher or any other work that you're doing um, starting tomorrow? In the sense that what's going to change in you with this? So these are the 9 things. I'll just go back once. Real life, outdoor, settings, reasoning, baby steps, art, designing, research, flip the class, poem, write. And then I come to the foundation of everything, which is why is your university making you go through um, these webinars? Is growth is necessary. If you don't grow, you die. It's like if plant doesn't grow, the plant dies. Mentally, emotionally, what is your growth model? In the sense that what triggers you to grow? What triggers you to say, I want to be better? And it also changes with life. For example, at one point for me, my growth model was, I need to be able to reach out to every child in my class. Then for a short time, my growth was, I really need money, and I need money to save, and I need money to buy nice things and to travel. Then it was, I want to go and help people, so let me start doing something for free. So we all have something that triggers us to grow. For me now, it is, what's the next challenge, what's the next project, or partly, how can I help people in doing something pro bono? So what's your growth model? Think about that. The other thing is, know yourself. Why am I doing this? It's like every day, end of the day, as a teacher, what happened well in my class? What didn't go very well in my class? And why was it? Uh, what is in my personality that is coming in my way to be a better teacher? I think anything that you're doing, and being a teacher is amazing, being a student is amazing, both. To see, why am I stuck if I'm stuck? So, for example, as a teacher, it would be for me, why am I not able to build a good relationship with the student? Today, it might be, why am I not able to trust this client? Or why am I not giving my best to this project? So, ask yourself, get to know. So get to know yourself is believe me, the better you understand yourself, the better you're outside, in your work, in your relationships, in your life, because you are not getting caught into somebody else's way of thinking. You are able to express your own creativity and originality. And then relationship, I think fundamentally teaching is relationship. What is your rapport? Relationship is rapport, a sense of friendship, a sense of positivity, trust. What a school principal once said to teachers is a sense of positive energy flowing between two individuals. And he said that's all he used to see when he used to assess teachers in the school. So, what is the relationship? Am I an authoritarian? Do I want control in the class? Am I a friend? Do I like to have a rapport? And am I giving something positive to the students? Am I giving something negative to the students? If you are a student, what's your rapport with your teachers? What do you want it to be? If you are an administrator, how's my rapport with my team? So, this is something we need to keep questioning all the time, is the bit about relationship. And the whole purpose of this presentation, of all the 9 ideas I gave you, was to make this shift. As a teacher, you can either be controlling or you can be nurturing. Either you can say, I'm the boss. Then you don't need any creative ideas, because you just tell that just do it. You do it because I've told you. Um, this is it. This is maths. This is a rule. So 1 by 2 into 1 by 3 is 1 by 6. That's a rule. 2 divided by half is 4. That's a rule. Or you can be nurturing. You can be nourishing. You can be a friend. You can find out the rule behind why 2 divided by 1 by 2 is 4. You can understand that there are always children in the class who love maths. There are always kids who are frightened of maths. So you bring left brain and right brain into the maths classes so that everybody starts liking it. So that is the shift between being obsessed with rigor of maths and only hundreds and hundreds of questions. And I remember we would do at least 500 problems in grade 12 just to get integral calculus right, to nurturing, where you're doing all those 500 questions, but maybe you allow some students to do 450 questions. And along with that, you do a little bit of designing, you do writing, you do information research, you do flipping the class. And as all teachers who have done this, I'm not the only one. I mean, there are tons and tons of teachers who have discovered that the more nurturing you get, the more you bring creativity. Actually, the content, the syllabus, everything goes faster because you've got enthusiastic kids in the class who want to learn. So you don't need to push them to learn. They love it. They are there. So this is the shift that we need to keep trying to make pretty much all our lives. And that is where just rigor, a lesson with just rigor, shifts to rigor plus creativity when the whole of the brain is nurtured. And that is the objective of this. Thank you so much. If you want to know more of my ideas, they're on my blog. You just have to type Humane Maths in Google and you will get it. Thank you.
Thank you, ma'am. Thank you for this wonderful and full of learning session. Ma'am, there are two questions.
Yeah.
They are from one of our maths faculty, Hemangi ma'am.
Mm. Yeah.
One is how to create importance of mathematics in students' mind of engineering field.
The only way is to connect it to real life. The only way is, every student in is, whether it's a grade 1 or engineering or post graduation, has only one question in the mind: why am I learning this? So if you have any topic of engineering that you're teaching, you need to also show to the students why are they learning. And if you have time, take them out, take them to industries, let them meet engineers who are working, call them to the college, let them talk about the use of this, let them bring with them their presentations, their PowerPoints, because engineering is completely an application based topic. So that is the only way. It's like you need to answer the question, why am I learning this, for every topic in the engineering textbook.
Thank you, ma'am. And the another one is, in board group A and B are separated. Is it worth that if the students want to take medical group, it has no need to study mathematics?
That is something which is very typical of India, and I don't agree with it, but this is not something I can do anything because it's a policy decision. Till 12th, I did both biology as well as maths, and I was actually in two minds what to do after 12th, and I wanted to do genetics, but genetics at that time was available only in post graduation. So, it's a policy decision. Ideally, I think students should be able to create their own set of subjects. What they do in the international schools is even at the 12th level, every subject has three levels: lower, middle, higher, and students need to study everything, but they can choose, okay, I'll do this at a lower level, this at a higher level. Ideally, that is the solution, but we'll have to wait. I think India is changing. I'm quite sure this also will come.
Yes. Ma'am, yes, we have covered all the questions. Thank you very
Mhm.
much for giving us your valuable time.
Yeah, thank you so much.
And thank you everyone for joining today's webinar. I would like to thank you, the HOD of our department, Mr. Hemal Patel sir, the HOI of our institute, Professor Jatin Vaidya sir, Academic Director, Dr. Mahesh Bhatt sir, and President of our university, Dr. Devanshu Patel sir, for continuously motivating and supporting us. Thank you very much.
Thank you.
Thank you.
Thank you,
Thank
madam.
you. Shall I log off?
Yes, ma'am.
Yes, madam.
Okay.